Hello. So air pressure is another one of those calculated measures and observations that we use all the time. And air pressure is such that it's a calculated force over a specific area. The force that we're talking about is weight. And we're going to go over weight and what that is and how that differs from mass as we go through this segment. So weight is very familiar to you. A person's weight is how much of them there is, but you know that there are weightless areas in our universe. And for instance, the ISS, the International Space Station, is nearly weightless. The moon is nearly weightless. Out in space, quite a bit farther out, you are weightless. So you know of that. That's familiar to you. So you know that a person's weight is based on how much stuff there is in their body and also on gravitational pull. And when we measure weight, we measure it on a scale. Scales measure the force of that gravity on the mass of the object, the mass of the person, the mass of the apple, the mass of the bag of oranges that you picked up at the grocery. That scale uses springs that counteract the force of gravity and measure it when you're measuring weight. Now, what is a force then? Well, a force is a push or a pull. It's an easy way to say it. When we're talking about the force of gravity, we're talking about a pull. We're talking about a calculation of pull between two objects. In the case of Newton and his theory of his theories of gravity, we're talking about the pull between the Earth and the apple. They pull toward each other. Now, the apple has a small bit of mass. The Earth has a tremendous bit of mass, so that the Earth is essentially doing all of the pulling. But gravity is a pulling toward each other. Planets pull toward the sun, and the sun pulls toward the planet. But it's all relative there. A force, in this case, a gravitational force, is a pull. And in this case, when you measure the weight of the apple, you're measuring the calculation of the pull on the mass of the apple. The calculation of the pull of gravity on the mass of the apple. You do that with a spring. You do that right in a grocery store. So weight equals mass times a gravitational constant. There's a gravitational constant for the Earth. You might have heard about it at 9.8 newtons. There's a gravitational pull constant on the moon that is much less. There is a gravitational pull on Pluto, which is much, much less. And I guess I'm dating myself because I still consider it a planet. If weight is mass times gravity, then what is mass? And how do we measure mass? So mass is matter made up of atoms that take up or occupy space and a volume. So mass is just matter, atoms that occupy volume. So our bones are matter, our skin is matter, our eyes are matter, our hands are matter. These are all different forms of matter. Mass is measured in kilograms. Mass is measured on a balance. It's not measured on a scale. Mass is independent of gravity. Just like a balance is independent of gravity. Once you get two sides of a balance equilibrated, you can take that balance up to the moon and it will still be balanced because you are measuring equivalence in matter and the volume it occupies. If you want to think about a balance that's really easy, get yourself a metal coat hanger and you can hang two pieces of string on it and you can balance things like a roll of dimes and a light teacup that you can thread the string to. And you can balance those two things until they have equivalent mass, equivalent amounts of matter taking up volume. If you took that equivalence up to the moon, they would still balance. So mass is not dependent on gravity at all. And in fact, mass is measured in kilograms. Grams go on one side of the balance. Then whatever you want to measure is on the other side of the balance. And mass is measured in kilograms. The English system does not even have a good unit for mass because we step on a scale for things. We measure in terms of pounds. Those pounds that we measure are actually known as pound force. You can talk about pound mass, but nobody does. So we really look at mass and the metric system and kilograms. We look at weight in the metric system and newtons, but we'll get into that later. Let's just make sure that you understand the difference between weight and mass on the Earth and on the moon. And on the Earth, a brick can weigh 5 pounds. And you know that on the moon, the brick is going to weigh far less. But on the Earth, the brick is going to mass at 2.3 kilograms. And on the moon, the brick is going to mass at 2.3 kilograms because mass has nothing to do with gravity. Really interesting point. So weight is mass pulled down by gravity, and air pressure is weight over a given area. Now, what's area? Well, how does area differ from volume? You know that volume is a 3D space that an object occupies. It can be a liquid object, a solid object, a gaseous object. Volume is measured in liters. It's measured in cubic centimeters. It's measured in ounces. Area is a two-dimensional space that just a surface occupies. And we can measure that surface, length times width, area. So pressure is the weight, the force over a surface area. And we'll specify that soon. Air pressure exerts weight over a certain area. Pressure and air pressure pushes with that force. Hope that helps you out. See you on the next one.